So this is 10-3 alpha. When they say paired data means blocking, it means matched pair or repeated measure. And what are we going to do? A confidence interval test. But the last one's the most important. Determine when it's appropriate to use a paired T procedure versus a two sample T procedure. And if you get this question in May, it'll be really easy for them to grade it because it'll probably be a difference between whether you landed in the body or the tail, whether you did this correctly. That makes it really easy for the readers to spot because your answer would be different. Okay? So we're doing exactly what we did over the last 2 days, except, and you read the example about the twins. That's why identical twins are studied statistically, because they have the same DNA. So it's essentially a very convenient matched pair. So here we go. We got these twins, right? Now there's 12 twins, numbered 1 to 12, and the A twin went to the high income family and the B twin went to the low income family. Are we good? So in order for this to be a matched pair, the sample sizes have to be the same. But converse error, if the sample sizes are the same, that doesn't guarantee it's a matched pair. You have to read the problem. Because some of the problems we did in 10-2, they had the same sample size, and another problem we did, they didn't. So, what happened here? Well, we want to do the conditions. And the sample size is 12, so it's not 30. We don't know anything about the distribution of the population, so we're going to draw a box plot to meet the condition. And instead of drawing a box plot, here they did a dot plot. So what's the difference between the IQs? The high income twins had a higher IQ than the low income twin. However, the sample size is only 12. Could that be attributed to chance alone, to random variability? That's what we're doing. Anyone can do this, okay? Anyone can read and say, that group's higher than that group. But your job is that statistically significant? The steps are different, okay? And again, we're not going to do this by hand, but what would you literally do? You would find the mean of the 12 in the A group, find out how far each one is from the mean, divide by 11, sample size take away 1, take the square root of that, and get the standard deviation. But the technology will do it for you. The depth of knowledge goes to you understanding what the technology did for you. So they're saying, look at that overlap. It doesn't look, one's higher, but it's a lot of overlap. We can't tell. So now we're going to do this differently. Now we're going to say, because it's a matched pair, instead of doing the samples independently, we're going to subtract vertically. So the difference is here, and you do a dot plot of the differences. Or actually, we're going to do a box plot of the differences. So instead of doing a two-sample procedure, which we did in section 10.2, if the data is blocked, we do a one sample procedure of the differences of the two. That's the mean difference. That's the step. Another data set, okay, which you previewed. How about music? There's 30 students to find out. Each took a 50-question arithmetic test with and without music. For each subject, the order of music or no music was randomly assigned. So then they recorded how long did it take everybody to do this. So do you understand what you're doing? In the problem about IQ, it was a matched pair. There were two people, they were twins. One went to a high-income family, one went to a low-income family. In this problem, it's repeated measures because it's the same person who is getting the treatment and the control. The treatment is music while they're doing the test, and the control is silence. So they're getting paired to themselves. And we have the difference of how much time it took if you're listening to music versus without. And the sample size is 30. It's large enough to use a normal t distribution for this. Okay? There is the difference. The differences. Which they did, which we didn't have to do. Why not? Hello? Why do you not have to draw that picture? Because the sample size is 30. That's why. That's what that picture does for you. So they did it. They did it. It doesn't mean it make, you don't need to. There's the step. These are both blocking measures. They're saying every individual gets the experiment and the treatment, or the researcher can form pairs of similar individuals. So you could say, take a pre-test on the arithmetic test and match the people up that had a similar pre-score, and then redo it, give them a different test where one gets music and the other doesn't. They're both blocking. In this slide, choice 1 is repeated measure, and choice 2 is matched pair. Here are the conditions. Same thing. SRS, or random assignment of treatment, less than 10% of the population, the sample size is at least 30. We're saying the mean of the difference between the two for the confidence interval. Add or subtract the critical value of the t-score times one step, which is the standard differences times root n, or divided by root n, which is the sample size. Okay? Here we go with the twins again. And you want a 95% confidence interval. Here are the conditions. Random sample of 12 pair of identical twins. Okay, this is a observation. They didn't impose this on the twins. They were already sent to these homes. Correct. If there's blocking, you do a one sample test. Okay. 12 is less than 10% of all the twins. The sample size was not large enough, so we had to do a dot plot or a box plot. Here's the value you would get. We good? So think about this. What we're telling you is, you're going to do it yourself. But if you're looking at this, you would go to this top row and put in list 1. You would go to the B row and put it in list 2. You would go to the top of your calculator in list 3 and do 1, take away 2. List 1, take away list 2. Yes? Suppose you did list 2, take away list 1. What would happen? It would just reverse your curve. It would be symmetric. It wouldn't matter. So what happened here? They did, right? Degrees of freedom is 11. The difference, there's 12 pairs in the sample. So here's your critical value. Meaning, the calculator does it for you to do the test, but you would get a multiple choice question where you'd have to identify the degrees of freedom. Here was the difference, the mean difference. That's the critical value. That's the step of those differences divided by the square of the sample size. And you get this. This number add or subtract that. That's your interval. Okay? Now, for that interval, ready? This is what you have. This is your null. The difference of the two, which is A, the rich twins, B, the low-income twins, is 0. Do we reject or fail to reject the null from that screen? Why? Zero is where? It's not in between the two values. That's all we care about. Is 0 in the interval? Is it? No. It goes positive to positive. What was the null? The null is the difference is 0. If 0's not in there, we reject the null. There is evidence of a difference in the IQ between twins raised in a high-income family and twins raised in a low-income family. If we did a test, ready? That's a 95% confidence interval. If we did a test, if it's a 95% confidence interval, then the alpha level is 5%, because these two have to add up to 1. Does that make sense? Yes? Because it would look like this. Here comes the curve. There's the confidence interval. And that would be 2.5% in each tail, and that's 100%. So tell me about the p-value. Is the p-value for this data larger than 5% or smaller than 5%? Without even doing it. This is the best CCD class of all time. Who went to CCD? Yes. Was the class this well behaved when you went? You people are the greatest CCD students ever. You're just sitting there quietly, meekly, cooperatively. We need people to think about the statistics. What would the p-value be here? Smaller. Thank you. Why, Jordan? Because you rejected the null. Correct. And if you reject the null, that happens when you land in the tail. And when you land in the tail, the p-value is small. This goes together. You need to see this connection. They will complement each other. If you reject the null because 0 is not in the interval, that means your p-value would necessarily be smaller than your alpha level every time. So if, ready, we are doing stat test, what is that, 2? Somebody look on their calculator. Tell me what the t-test is. Stat test 2. So what's going on here? Well, yeah, in 10.2, we use stat test 4 and we use stat test 0. Stat test 4 was the 2 sample t-test where we used 2 lists. And stat test 0 was the 2 sample t interval. And now we're doing stat test 2 because we only have 1 list, the list of differences. And what are we testing? We either have the data or the statistics. But the null is that it's 0. The null is that list 0, that list 3, the difference between the two, would be 0, that there's no difference. Okay? And then this was on the PowerPoint. That's what you have. I have the mean of list 1 take away list 2, add or subtract the t-score times the step of list 1 take away list 2 divided by root n, the sample size, which is going to be the sample of the differences. So if you had 10 in each list, then it'd be root 10 because you'd have 10 differences. Okay? So we're going to pause this video and send you to one data set. Problem 75 and 79 deal with the same data set. Okay, so for problem 75, they're asking you what is the mean difference. So I put the differences in a list. I got 4.556, which is in thousands. So the estimated mileage using weight is that 4,560 miles, thousands times that, more than the estimated mileage using groove. And there's the one step added right or left. But in order to calculate whether that's significant or not, we do a t interval of the list of differences, 95% interval, and we get positive to positive, so we would reject the null. The null being that the difference is 0. So tell me what's going to happen about the p-value. Has to be smaller than 0.5 because you rejected the null. It's the same things we set up here. It's a 95% confidence interval. So our alpha level is 5%. If we rejected the null for the interval, ready, it was positive to positive. Here's 0. We landed out here somewhere because it's positive to positive. So that means the p-value is smaller than the alpha level. Go ahead and calculate it. What do you get? Stat test 2 using your list of differences, and what is the p-value when you calculate it? Jordan. Is it, okay, how small? Is it scientific notation? It's essentially 0. The p-value is essentially 0, which you anticipated. It has to be less than the alpha level because you already rejected the null by doing the confidence interval, and those two results will complement each other.